Hey guys, today we're going to talk about solving literal equations, meaning you have a lot of different variables in one equation and you're asked to solve for a specific one of those variables. We've learned this in class already, but if you guys want some more practice and you want to do these examples with me, let's go through them. So the first equation I have is 12g plus 31h equals negative 8g. Okay, and our goal here is to solve for h, okay? So the first thing that I would do when I'm trying to get this h by itself is I want to move this whole chunk of 12g. Now I'm not trying to split up the 12 times the g, I'm just trying to move the whole term over to the right side to get it out of my way. So since this is a positive 12g, I'm going to subtract 12g from both sides. Okay, this is going to get it off of the left side and onto the right side of my equation. So I end up with 31h equals negative 8 minus 12g, which is 20g. Okay, from here, again, my goal is to solve for h, so I'm trying to get h all by itself, which means I need to divide out the 31. Since this is 31 times h, I'll need to divide it out. So I'll also divide it here. Now, I end up with h equals 20g over 31. And it is perfectly fine to leave that as a fraction unless it can be reduced, and in which case you would need to reduce it. This can't be reduced, so we're going to leave it as 20g over 31, and this is h. A lot of the times we have issues with these type of literal equations because you don't get down to h being an exact number. Instead, you get that h is some sort of expression with maybe another variable within it. In this case, h is 20g divided by 31. That's fine. That can be your final answer. You do not have to go any further. Most of the time with these literal equations, you're not going to come out with a number answer. Okay, so let's look at a little bit more simple example. I've got 5t minus 2r is equal to 25. Okay? So this one asked me to solve for t. Okay? So I'm going to solve for this t right here, which means this 5t, since it has the variable that I'm actually trying to solve for, I don't want to touch it till the very, very, very end. So instead, I'm going to get rid of this negative 2r. This is minus 2r or negative 2r. So if I want to move it over, I'm going to do the opposite by adding 2r. And I can't really do 25 plus 2r because they're not like terms. So I simply write that 5t equals 25 plus 2r. Okay? Now I want to separate the 5 from the t. And since this is multiplication, I'm going to divide out my 5 and divide out my 5. Okay? So my 5s are going to cancel. I'm going to be left with t equals 25 plus 2r over 5. Now this can also simplify. Okay? So we just saw that we can break this down into two fractions. We can break this down. We can break this down into 25 over 5 and 2r over 5. And we see that one of these simplifies down. So this here is going to simplify to 5 plus 2r over 5. And that's going to be equal to t after I've reduced everything. So again, if you have a big fraction, split it apart into two fractions and then see if there's anything you can reduce like we did with the 25 over 5. This would be your most simple form of the answer. Is 12 a.m. is equal to 4. And our job is to solve for a. I have 12 times a times m. They're all being multiplied together. To separate any of them, I would need to divide them. I can go ahead and I can combine the 12 and the m and divide them out together so that my 12s cancel and my m's cancel, and I would need to do the same thing here. Okay, so this leaves me a equals 4 over 12m, and I can reduce the 4 over 12, so this would be a equals 1/3 m, or 1 over 3m. All right, so in this problem, again, we're solving for h. This obviously looks very different. It's much longer. It looks really scary. You have pi and you have squared. Don't worry about any of that. You're solving for h, which is right here all by itself, okay? So it's going to be pretty easy to move some of this stuff out of the way. The first thing we want to do, since h is in this chunk over here, we don't want to touch that until the very, very end. Instead, we're going to look at this first chunk, or this first term. Now again, this is 2 times pi times r squared. But I'm not trying to separate the 2 and the pi and the r. I'm trying to take the whole term as it is and move it over with my a to the left side of the equation. Well, since this is just a big addition problem and 2 pi r squared is positive, to move it over, I can simply just subtract it. Okay? And I'm going to subtract it from both sides. That's going to cancel off of the right side of my equation, and it's going to put it over with the a. So ultimately, I have a minus 2 pi r squared is going to be equal to this chunk here, 2 pi r times height. Okay? Now, I'm really not even worried about the fact that there are pi's or that there's an r squared anymore because h is over here. In order to leave that h all by itself, I do want to separate 2 pi r from h. And this is 2 pi r times h. So in order to separate them, and I can separate them all at once. I don't have to take out the 2 and then take out the pi and then take out the r. I can simply take out 2 pi r all at the same time. Okay? And when I do that over here, I'm going to take out 2 pi r all at the same time again. So my 2's cancel, my pi's cancel, my r's cancel, and I'm left with just an h all by itself on this side. Okay? So I want to give myself some room. Since these all canceled, I'm just going to erase them, and I'm left with h over on this left side. Now, if you got your answer down to here, that's awesome. I do want you to see that you can reduce this even further, okay? I could, anytime that you have an addition or a subtraction sign on top of a fraction, you can break that apart into 2 different fractions. So we can say a over 2 pi r minus 2 pi r squared over 2 pi r, okay? And we can write those as 2 separate fractions. So we're going to say a over 2 pi r minus 2 pi r squared over 2 pi r, and that equals h. Now the purpose of me splitting them apart like this is so that now I can reduce. Now I can simplify. Hopefully you see in this second chunk, you've got 2's that can cancel, you've got pi's that can cancel, and you've even got some r's that can cancel. Okay, so I want to show you how to do that. I want to expand this just a little bit and show you how you would simplify this problem even more. So I have a over 2 pi r, there's nothing I can do there, minus 2 pi r squared over 2 pi r, and this was all equal to h. So I want to show you that your 2's are going to cancel. Hopefully you see that. Your pi's are going to cancel. You should see that. And I've got r squared over r. Well, let's take that r squared, and instead of writing r squared, let's actually expand it out to what it really is. R squared is nothing more than r times r, okay? Hopefully now you can see that one of your r's is going to cancel with the bottom r. So I have a over 2 pi r on the left, because nothing can be done there, minus everything canceled except one of those r's. And that's going to be equal to h. Okay? So again, if you got it down to the beginning, to where we got it down, that's fine. If you want to simplify even further, which would be mathematically correct, this is how you would do it. All right, so my next equation is g equals b minus ca. This equation has no numbers in it at all, and my goal is to solve for a. So if I want to get this a by itself, I don't want to touch the ca part until the very end, because this includes my variable. I touch it last. Instead, I want to get rid of this b, and this is a positive b, so to get rid of it, I'm going to subtract it from both sides. Okay, that's going to give me g minus b equals negative ca. Now I can break apart the negative c and the a. Because it's multiplication, I can break it apart by division. I want to go ahead and divide out the negative c. so that they'll cancel, and I'll divide out a negative c here. Okay? Now, since I'm dividing by a negative, all of those signs are more than likely going to change. Okay? So we could imagine if I were taking all of this and dividing by a -1, all the signs would change. So we would now call this negative g plus b over c is equal to a. U equals 3b minus 2a plus 2, and we are solving for a. Okay? So since this is the piece that has the a in it, we don't want to mess with it until the very, very end. So the first thing I would do is I would get rid of the 3 times b. And since I'm not trying to separate 3 times b, I'm not going to do division. I'm going to take the whole positive term and I'm going to move it over by subtracting it, because that would be the opposite. So I'm going to have u minus 3b is equal to negative 2a plus 2. Again, since this is my part that has the variable that I'm looking for, I don't touch it until the very end, which means I need to get rid of this 2 by subtracting. So now I've got u minus 3b minus 2 is going to be equal to negative 2a. Okay? Now I'm to the point where I want to separate the negative 2 and the a from each other, and they're being multiplied. So to separate, I would divide out a negative 2. Okay? Since I'm dividing by a negative number, all of my signs are going to change. So I'm going to end up with a negative u plus a 3b plus a 2 over 2. And if I break this apart, these two 2's would cancel each other out. So I would have negative u plus 3b over 2 is equal to a would be my final answer.